guys. So in the last video we spoke a little bit about fractions, right? We introduced them and kind of classify them as proper, improper, um, mixed number, and what to do in the case of multiplying them. And I wanted to expand on that just slightly. So we're going to continue talking about multiplying fractions, right? However, with a kick. Um, so let me just briefly again go over that one rule. So we introduced that one rule, right? Um, ooh, not good. My USC pride. That's bad. All right, so I'm a groupie, you guys. I'm a groupie. All right, so check it out. We had A over B, so times C over D. So we're gonna just simply multiply straight across, right? And it works in a case like this, right? And if you need any review, just go ahead back to my previous video and you can check it out, right? Well, what happens in the case if we have multiple fractions? So if we have 3 over 8 times 2/5, right? Times 1/2 times, say, what's a good one, you guys? 6/5, right? Times 9, let's say 1/9 or 2/9, it don't matter, right? We can have plenty of them. How about improper? Let's say 8/3. Oh God! I write so sloppy. I can't believe it. How am I even still able to do this? I swear. Oh man, what's going on here? Okay, well, you get the point. Okay, so we have multiple fractions, right? So this is an example. You know what? Let me take my time with this. I don't know why I feel rushed. Something's happening here, you guys. My pen's messing up a little bit. It's overly sensitive. I don't know why. Okay, so example, right? So we have 1, 2, 3, 4, 5, 6. So we have several fractions that we have to multiply, right? Now, the rule states that we just simply multiply straight across. Boom. So it'll be 3 times 2, right? Times 1, times 6, times 2, times 8. And you're going to get one large number. And then multiply every value in the denominator. And you're going to get one large value in the denominator, right? Now, we can forego, or I want to say that, but I want to, so we're going to have one extremely large number, A, over one extremely large number, B. Jeez, can't be this sloppy. My mama taught me better than this. Alright. Hey, oh God, the pen is really acting up. Yeah, we'll blame it on the pen. Yeah, that's a good one. A over B, right? Just one extremely large number, and then at this point you're gonna have to reduce, right? Right, somewhere along the line. And instructions might say that, hey, reduce, reduce, reduce. You don't want to leave it in its unreduced form. I don't know what the opposite of reduced is. It's larger form. Oh man, I hope you guys can read that. It says reduced. R-E-D-U-C-E-D. Okay. My pen's acting up. No, seriously though, it is. I do write sloppy, so I guess those two factors combined really make for a really bad presentation. So excuse me. So anyways, we can multiply across according to the rule, right? So multiply across and get A over B, and then we're going to reduce, or we can simply look for factors that can cancel out along the way and then have that reduced fraction at the end, or have the outcome in reduced form already. So we can take it in this preliminary step, or at this step, right, before multiplication, and identify which factors do they share. So now essentially you're looking for a number divided by itself. So when I say that, if I say 8 here is present, I am going to look for 8 in the numerator somewhere, right? So I have 8 in the denominator. I'm going to look for 8 in the numerator, right? Or I can simply break 8 up into factors, and its individual factors, right? Say 8 equals to 2 and 4, 2 times 4, right? So I can say, hey, 8 equals 2 times 4, right? Then I can look for either 2 or 4 present in the numerator, right? Or I can say, is there anything that's a factor of 8 on the top? So if I see in the numerator, right? The numerator set, right? I can look for anything that's a factor of 8. 8's a factor of 8, 8 and 1, even 24. So if I see 24 on the top, right? I say, well, 24 equals to what? 8 times 3. So I said that's a factor of 24. So I can go ahead and find 8. So essentially, what I'm trying to identify is a number divided by itself. So I'm going to write this in terms of not constants, but what do you call it? Symbols. A over A. So anything divided by itself is 1. Again, a number divided by itself is 1, and anything multiplied by 1 is itself. Right? Those are two handy dandy properties to remember. Right? So anything divided by itself is 1. Right? So I see here that there's an 8, and then I have an 8 on top, right? So 8 in the numerator, 8 in the 8 in the denominator, 8 in the numerator. So we can cancel those out and yield the value of 1. Right? So that's not bad, right? What about 5? Do we have anything that's a factor of 5 on the top? I don't see anything. 2? Sure. I actually see a 2 right next to it, right? So we can cancel that out. That becomes 1. Now you see it's going to be 2 over 2. How about, no, we already established that 5 is not present. What about 9? Check it out. So we have 9 can be broken up into individual factors. I see 9 here, and I see factors of 9 on top. So I see a 3, right? Because we know 9 is 3 times 3, right? And we'll also see 6, because 6 is broken into 3. Oh, jeez, that sucks. I don't know what's going on, you guys. I'm so sorry. This will probably be a bad presentation. It's probably because it's late at night. Right? 6 equals to 3 times 2, right? That's all I did. I simply wrote 6 in terms of factors, and a factor of 3 times 2. Now, I can go ahead and cross cancel anywhere I want, right? I can say, well, look, check it out. I have 3 here, or I have 3 here. Don't matter. And I can break 9 into its factors, 3 times 3, right? And realize that here's a 3, and here's 1, 3. So we're left with 1, right? And we're left with 1 times 3. Cool? Same thing here. Look, 1 more 3. Oh, look. We can utilize that 3. So that's 1 here. And then we have 1 here. 1 times 2. Right? So we can rewrite this. Let's make it a little bit cleaner. And again, if you need to, what is this right here? My eraser's not working. Yeah, it's definitely the pen. This time I can blame it on the pen for sure. This is a 1, by the way. Because once we reduce 2 over 2 with 2, we're left with 1 over 1, or 1, simply 1, right? check it out. Let's rewrite this just so it appears clearer. Because this is 1 over 1, it's 1. We can kind of just leave that out. Right? 1 over 5 times, what is this? We already reduced this somewhere along the lines, did we not? Here we go, 2 and 2. Yeah. So 1 over 5. So we have 1 over 1. We don't need to rewrite that. We have 2 over 5 here, right? 2 over 5 here. So that's 2, right? And we reduce this 3 here with, I think it was this 3, right? Or this 3. Doesn't matter. You can reduce it with any 3. But as long as we went ahead and found was able to reduce it to 1, that's fine. And then here we have 2 over 3, right? Times, did we reduce 8? I don't know what this is. I'm so sorry, you guys. Yeah, we did. We did. To 1. I don't know what this line is over. And it's not working. It's alright. Alright, so 8 here. 8 here. That's where that line comes from. And 8 here, just to recognize, right? So 8. It's 1 over 1 right here. 1 over 1. So we're essentially just left with this. My pen is seriously not working. Wow. It's not good. Alright. Just when I was happy because I thought the technology was working and everything was great. Alright. So now that we've simplified this expression and by reducing, right, we can go ahead and actually commit to the process or the function of multiplication, right? And we can follow that rule. Simply multiply across 1 times 2 times 2, or what, 4? 5 times 5 times 3, so 25 times 3 is 75, right? And if my multiplication is off, I'm sorry. I make errors, plenty, and several of them. But hopefully you get the point. Cool. So let's try another one. I don't know what's going on here. It's stuttering. I'm going to pause it real quick. You guys are going to just realize a little glitch, but I don't know how long it's going to take. I'm trying to fix this error. Give me a second. Okay, sorry about that, you guys. I'm back. Okay, hopefully that fixed it. I made a quick adjustment. Okay, so we just finished this problem right here, right? Okay, let's make another one. So example 2. And by the way, this is all off the top of my head. I have nothing pre-planned or pre-organized. Let's go with this. So we said 2/5, right? Times, say 15/3 times 3/2 times, say let's throw in a mixed number, 1 and 3/4 times 2 8 or 8 over 2. Yeah, 8 over 2. That's what I'm talking about. You're gonna learn today. Kevin Hart, Kevin Hart. No? Anyone know Kevin Hart? Alright. So, first of all, I see this improper, I don't want to say improper fraction. It is, but it's a mixed number right now. It's a mixed number form, remember? Mixed number. Mixed number. Keep that in mind. You might see that terminology somewhere. Okay, so what we're going to do, let's just go ahead and convert that. Why not, right? So rewrite this, but with this converted, 1 and 3/4, and you'll if you need the review on how to convert mixed numbers, go back to my previous videos. or video, or you can look at the handout that I supplied. Alright, so what we're going to do, we're going to multiply 4 times 1 plus 3, so 4 times 1 is 4, plus 3, 7/4. And now you're in improper fraction. So we can replace 1 and 3/4 with that. Eight over 2, by the way, you can realize, I don't know why I wrote that like that, but hey, realize automatically off the bat 8 over 2 can be reduced. So what? 4. 4 over 1, right? Cool. Or simply 4, but to maintain this outfit, this fractional outfit, then I would write it 4 over 1, just for practicality's sake, right? Alright, check it out. Do we see any common factors in the bottom and top that we can reduce? Oh, look, check it out. I know 15 is a product of 15 and 3, right? So 15 and 3, right? So I can cancel out 5 and 5, that becomes 1. I see 2 and 2, why not? I see 3 and 3, ooh, good one right there. Oh look, 4. See, since we'd reduced 8 over 2 here, right? It became 4 over 1 here, in this spot. And now that we have 4 present, we can now see that 4 reduce, right? So we simplify this entire expression pretty much. So this is 1 over 1. This is simply 3, right? This is also 1 over 1 because we found its factors elsewhere and to be able to reduce. This is 7, right? And this is 1 over 1. 1 times 1. So I'm going to rewrite this now, right? So 3 times 7, actually. And I think that's all I'm left with. Equals to 3 times 7 is just 21. That's your answer. So what initially looked intimidating, all this example 2, right, with the mixed number here in this slot, actually just resulted with a very simple answer. As long as you can troubleshoot it and go to those various processes of, like, for instance, reduction and conversion, all that stuff, it doesn't look so intimidating at the end. I actually quoted in class, and I apologize because I thought it was Eazy-E that said this, but I got corrected when someone said it was Snoop Dogg, but I kept insisting that it was Eazy-E, but then I realized, oh my God, it was Snoop Dogg. I actually said, I quoted this, your bark was loud, but your bite wasn't vicious, and usually that's what you get with math. You get a lot of barking going on, but nothing too intimidating once you learn how to work with these guys, with these things, and how to convert, right? So it becomes like a fraction, like everything else. It looks consistent with everything else, and then you can reduce, and you're just limiting factors. That way you can break it down to something as simple as 3 times 7, and that's manageable, right? So, moral of the story: don't feel so intimidated, you guys. Math is difficult when you first look at it, but it's something but a big baby. Alright, you guys, take care. I'm going to continue these videos. We'll go on to adding fractions and subtracting fractions. So hopefully you guys enjoyed. Thanks.